Alright, this video is going to cover Unit 14.1 and 14.2. 14.1 talks about expressions of equality. So an equation is a mathematical statement of equality between two or more quantities. So if I had something like 7 equals 7, so I've got 7 on both sides, so that equal sign is valid. It's kind of like a balance right here, like you see at the bottom of page 420. Figure 14.1 shows a balance with, on the left side, 3 pounds, 5 pounds, and 2 pounds, and on the right side, 4 pounds and 6 pounds. So both of those sides is the same, equals 10. So therefore, it is in balance or equal. Figure 14-2 shows the 2-pound block being taken away. It's no longer in balance, therefore it's no longer equal, and one side is heavier than the other. So that's really the main thing that 14.1 is talking about. Just trying to get you to establish what the equal sign means. So if I had something like 8 equals 5, that is not equal, so that equal sign is invalid. Okay, so at the bottom of page 421 we have an example there. It says, what must be added to a 12-pound weight so that it will be in balance with a 20-pound weight? So we have a 12-pound weight here. We're adding something to it. At the moment we don't know what. But we know that it's going to be in balance with or equal to 20. So obviously what we add to it would be an 8. So 12 plus 8 equals 20. So that would be in balance. Now, when we talk about equations, you're also going to hear the term expression. If you had an expression would be something like 2x plus 3. There's no equal sign there, so therefore it's just an expression, an algebraic expression. So if we set it equal to something, like equal to 5 plus x, then we have an equal sign. So this is an equation. Just one of these is what we call an expression. All right? So let's turn to example 2 on page 422. It says, in a series circuit, so we have a series circuit right here with 3 resistors in it, and those 3 resistors have a source voltage of 120. So in a series circuit, you can add the voltages in the covered by the resistors, and that will equal the source voltage. So it gives us some stipulations as to what the voltage drop across each of those resistors is. It says that the voltage across resistor 2 is twice the voltage across resistor 1. So resistor 2 is equal to 2 times R1. And then it says the voltage across resistor 3 is 3 times R1. So R3 is equal to 3 times R1. So over here we have the equation for all 3 of them. R1 plus R2 plus R3 is equal to 120. So we know if we add them all together we get 120. But we have 3 unknowns here, and we cannot solve for 3 unknowns in this situation. So these 2 equations right here will help us put R2 and R3 both in relation to R1. So if I substitute for R2 to R1, so we'll write R1 first, plus R2, which we know to be R2 times R1, then plus R3, but we know R3 to be 3 times R1, and we know that that's going to be equal to 120. So we have one variable now, which is R1, so we can combine all of our like terms. So I have 1R1 here, 2 here, and 3 here. That gives us 6 times R1 is equal to 120. So using algebra, we divide both sides by 6, and what that does is make this a 1. So now I have 1R1 on one side. So what I've done to one side, I have to do to the other. Divide this side by 6, and that gives me 20. So the voltage across R1 is 20. So I can write R1 equals 20. And I know that from this equation right here that R2 is 2 times R1. So R2 would equal 40. And I know from this one right here that R3 is 3 times R1. So we know that R3 is going to be 60. Okay, so now I can go back up to this equation right there and write these numbers in. So I'll just write them right here. We know that R1 is 20, plus R2 is 40, plus R3 is 60, and yes, 20 plus 40 is 60, plus another 60 is 120. So adding all of those up, we get back to what we know we should have had, which is 120. So this equal sign is a balance. So the same amount on both sides of the equal sign. Now, let's take a look at some of the exercises here. But before we do that, I want to note something about the way the exercises in this book are laid out. On page 423, about in the middle, you see the exercises for 14-2. The first things that you're always going to see are what's called power-ups. And what that is just a look at something that has been covered in the book already. Well, we haven't covered anything in the book yet, so those aren't going to help you much. They're usually not going to help you because it could be from any section previous to the book, and we are not going to cover every section in the book. So let's take a look at some of these problems near the bottom of page 423. Let's see here. Which one looks good? How about number 16? Number 16, it says, twice a number plus 3 times the number equals 20. Twice the number, so 2 times the number, which I'm going to use x, plus 3 times the number, so plus 3x equals 20. So that's how we would write it. And of course we combine our like terms here to get 5x equals 20. So therefore you can just envision this. If not, you can algebraically solve it by dividing both sides by 5, and you would get x is equal to 4. Now let's look at 17. 10 times a number. So I'll write that over here as 10 times a number, and I almost always use x. I don't have much of an imagination, so I just use x. 10 times a number minus 4 times the number. 4 times that same number is equal to 42. So now once again, I'm going to combine my like terms. So now I'm subtracting. So I will have 6x equals 42. Notice how I still have an equal sign here, but I've changed what one side looks like, but it's the same thing mathematically. So now divide both sides by 6, and I've got x is equal to 7. Let's see. Oh, another good one is 18. 3 subtracted from 3 times a number, plus twice the number. So 3 subtracted from, I don't know what, at the moment I don't know what 3 is being subtracted from, so I'm just going to say, give some space there, subtract 3. 3 subtracted from 3 times a number, so 3x plus twice the number, plus 2 times that same number is equal to 27. So over here, I will combine my like terms to get 5x minus 3 equals 27. Continuing to solve, I will, in order for this equal sign to maintain true or maintain equal, if I do something to one side, like I need to get rid of that 3, so it's a negative, so I add to get 0. I've added 3 to the left side. In order to maintain that balance, I need to add 3 to the right side. So I will have 5x equals 30. Then divide both sides by 5, and I have x equals 6. Oh, let's see if there's another one here. Let's take a look at number, which one am I looking at? Number 27. Okay, number 27 is figure 14-8. And as you can see, what we have here is some distances that add up to be, we know that they add up to be 27. All right? But what are they? They are x plus 3x plus 5x. And they equal 27. So we add these all up. We would have 9x equals 27. Divide both sides by 9. And I would have x is equal to 3. All right. There are several others in here that you can take a look at. If you find one and you want to try it, just go ahead and try it. If you have trouble with it, just let me know. And have a good day.